Good evening, everyone. So today we will be discussing the filtration process. So before starting today's session, I will wait few more minutes for people to join for the live session today. Okay, so today we will be discussing filtration process. I'm Smita Mondal. I'm PMRF scholar in Department of Chemical Engineering Department, IT Madras. Let's start today's session. So we will discuss at first the fundamentals for filtration process. So here we know that filtration is defined as the separation of solid and liquid. We are separating solids from liquid by passing a suspension of solid in a liquid through a permeable medium which which retains the solid particles. The product can be from the filtration process. The product can be either the solid particle that has been entrant that has been trapped, or it can our desired product can be clear liquid based on our requirement on the process. So you can see this is the simple schematic diagram that represents the filtration process. This box denotes that it is of having some filter medium, and this is of hardware, filtration hardware, and it has some filter medium which has certain porosity. You can see. Now, when you see this porosity here, so you are going to pass through the suspension of solid and liquid through the porous medium at a constant pressure for one condition, or might be at a constant pressure, constant flow rate or constant pressure. So the pressure it being the pressure difference it cause due to the passing due to the case of passing through the porous medium, some pressure drops occurs through the upside and downstream process, That pressure drop we denote as P2 minus P1, or that is P1 P2. So pressure drop will be P1 minus of P2. So this is the simple, very simple knowledge for filtration. Now, depending upon the filtration equipment that you are using, there are various driving force for filtration. We will discuss one by one. And when there is lot of different design for filtration equipment, this this fundamental concept for filtration applies everywhere, but the force acting for separation of liquid to separation of solid from liquid, it differs from equipment to equipment. So in order to obtain fluid flow through a filter medium, a pressure drop has to be applied across the medium to maintain the flow of the slurry through the medium. So this pressure drop can be achieved by four types of driving forces. The forces are gravity, it can be vacuum, it can be pressure driven, or it can be centrifugal force. So this system and the simplest form of filtration that I just have discussed here, this can be an example of gravitational force or vacuum force or pressure driven force. So there are basically two types of filtration used in practice. Basic two types are, one is surface filter and another one is the deep bed filtration process. So surface filter, you can understand by its name that it is used for cake filtration, in which the solids are deposited in the form of a cake on the upstream side of the relatively thin filter medium, while the depth filters or the deep bed filters are used for the particle deposition, where that is taking place inside the medium, not at the surface, it is happening inside the medium, and cake deposition on the surface of that filter in case of the deep bed filtration is not desirable. So this is the basic difference between surface filtration and deep bed filtration. So in case of the surface filtration, the filter medium has a relatively low initial pressure drop, and the particles of the same size or particles which is larger than the opening of that filter medium, they basically create some smaller passages which remove even smaller particles from the fluid. A filter cake thus formed on the surface of the filter medium, which in turn functions as a medium for the filtration for the subsequent input suspension. Now, in order to prevent any kind of blinding of the filter medium, some filtered aids are very important to be used as a pre-coat, which forms an initial layer on the medium. So what is happening by using the filter aids, that it has higher porosity in nature. So when it has higher porosity, it gives more space and it prevents thus the blinding mechanism, the blinding issue of the filter medium. So some penetration of the fine solids into the pre-coat or into the filtered aid or the medium itself is sometimes inevitable. We cannot stop this process. But adding filtered aids into the system of filtration will definitely help to prevent the filter medium blinding issue. Okay, so moving on to the process of filtration, we can see that there are two different types of filtration. And uh, the process is thickening process. It is also a process which makes the solid particles separated from the liquid stream. So in the thickening process, it is the process where the slurry or the solid liquid mixture is separated to a dense slurry containing most of the solids and an overflow which is essentially clear liquid. So you can see a thickener here in the picture. So the feed slurry and some polymer for um, enhancing the rate for thickening is introduced into the thickener, and over the process the rack is rotating and the solid particles settle down at the bottom of the thickener, and the overflow that you can see, this is clear water. So this is what the thickening process also very common in water processing industry and a sludge processing industry. So it is very common practice using thickener to separate solids from the liquid stream. So here the driving force for the separation is basically gravitational force, where the differences in the phase densities drive the separation of the solids and liquid. So the desired product of the thickening process that we are basically desired to collect over the period, that is the settled solid at the bottom of the thickener, and we will collect from here. And this rack that is rotating, you can see this will scrape the solid particles in such way, because it is a motor, it will rotate and it will scrape, and thus it will concentrate all the materials at the center of the conical shaft and it will be collected from the bottom. Now another process, that is clarifying process. It is also a process for separating solid liquid mixture. So in this process, liquid is separated from the um, okay, this is solid, sorry. In this process, the solid is separated from the liquid present in the slurry, feed slurry, with the help of some filter media to obtain the clear liquid. So here we are using the filter media to um, successfully operate this um, liquid and solid separation process. So this process is more likely conventional filtration process that I have just discussed in the previous slide. The desired product is obviously clear liquid for clarifying process, and so when we discuss the entire filtration process, so it will follow some steps and we can divide it like the filtration process. It consists four main steps. First one is filtering. Second one, we have to wash the cakes or the solid cake bed so that we um, remove the impurities from the solids if our desired product is the solid product, and then drying of the cake in certain thermal condition, and then removal of the cake. So these are the four main steps for entire processing of the filtration process. So when we discuss about um, the filtration process, it is more about some principle that we have discussed. So we will just now discuss about what are the most important factors influencing the rate of filtration. That is very important to know because we will discuss most of the factor in the upcoming slides. So first one that is very important to understand, that is the pressure drop. So the pressure drop from the feed side to the far side of the filter medium. This pressure drop is very important, and then the area of the filtering surface. And the third one is viscosity of the filter that you are handling. Fourth one is resistance of the filter cake. It is very important. And also an important part is resistance of the filter medium. And initial cake layer. So this important parameter that you have to focus on before operating the different kind of filtration process. The most important thing is the pressure drop, the area for filtering surfaces, viscosity of the filter that you are going to get, and the resistance for filter cake or cake bed, also the resistance of the filter medium, and the initial cake layer. So next we are going to discuss about the simple filtration process, that how we are calculating the volumetric flow rate through the filter medium. So this involves basic involvement of some resistance of the that parameter that we already discussed now, that is the total resistive force uh, for including the cake resistance and the filter medium resistance. So it involves that you can see a filtration process. Here the piston that is being used for pressing the cake, and all the filtrate will pass through the medium that has some certain porosity, and it will collect, and filtrate will collect at the bottom. So this is how these particles, solid particles in the slurry, will be stuck onto the surface of the filter medium, and only the liquid or the filtered part will pass through the capillaries, and they will be collected at the bottom of the filter press equipment. Now here what is written, that semi-permeable membrane that permeates the passage of the liquid and prevents any solid particles from permeating is one of the main component of the filter. Now the membrane comprises a large number of the capillaries forming tortuous channels for fluid flow, and most of these channels are continuous. So here we have assumed that the passage of the fluid is kind of streamlined, and it is reasonable to assume Poiseuille's law of the fluid flow through the capillaries is, is quite applicable to both filter medium and the cake medium. Now the Poiseuille's law states that rate of filtration per unit area of the filter bed will be equal to the ratio of the driving force to the product of the total resistive force and the viscosity of the fluid. So this is kind of a statement of the Poiseuille, and we will apply the same logic for calculating the volumetric flow rate through a filter. So here for filtration, the total resistive force represented by RT is nothing but the summation of the resistive force of the medium, filter medium, Rm, and the resistive force of the cake, which is Rc. So total force can be written as Rt equals to Rc plus Rm. Now another assumption is the structure of the cake doesn't change with pressure. So we are assuming that the cake is incompressible in nature, so it cannot be compressed. The resistance of the cake will be proportional to the mass of dry cake deposited during the filtration. So Rc equals to mc by A, where mc is the mass of the dry cake, area is A, and A is the specific cake resistance. And the unit for specific cake resistance, that is meter per kg. Now when we define the Rc, that is resistance inside the cake layer, so we have to now derive the volumetric flow rate through the filter. If now V is the volume of the filtrate that is being passed through the filter with the time t by the application of the differential pressure del P, then according to the Poiseuille's law, that is this law, the volumetric flow rate will be dV, that is the volume, by dt, that is A into del P by mu into RT. RT is the total resistance. RT can be written as Rc plus Rm, and Rc can be again substituted by mc alpha by A plus Rm. So this is one of the important equation when you are using the filtration concept, and it is being applied everywhere where we are dealing with filtration. So this volumetric flow rate that you are getting here is simply dependent on the area of the or area of the filtration bed, the pressure difference from upstream to downstream, also dependent on the mass of the dry cake has been produced, dependent on the cake resistance, dependent on the um, filter medium resistance, also the viscosity of the filtrate. So it is very important equation. The next one is when we are willing to uh, incorporate the term permeability, because we are dealing with some porous material, so there are some permeability factor as well. So so this equation that in the last slide we have derived, it assumes that the flow through the capillaries are in the porous medium are streamlined, but in reality those are not streamlined, and the resistance of the filter medium is constant, which in practice they are not always to be true. Further, the resistance of the cake is assumed to be uniform and constant, which is also not an ideal case. Particularly, cakes are generally compressible in nature, and there is some relation when the pressure difference for the pressure drop in the cake layer is somewhat related to um, it is related to some compressibility factor, and this resistance in the cake is obviously a function of surface area, specific surface area of the particles forming the cake layer, porosity, and the diameter of the each particle. Then specific surface area can be written as, considering the spherical particle, it can be written as 6 by dp. Porosity uh, is nothing but the ratio of void volume by total weight volume. So working with some porous media, Darcy's law established that pressure drop del P of a fluid flow flowing through porous media. By Darcy's law, it is del P equals to volumetric flow rate into length of the porous media, viscosity of the filtrate, K is the permeability constant, and A is the area for the filter medium. So this permeability constant is defined as the permeability of the porous media, and this permeability is also related to specific cake resistance by this formula, where K equals to 1 by alpha y minus porosity into uh, density of the spherical particles. So ultimately, when you substitute these extra equations in the previous equation in the previous slide, you will get a simplified form where the fluid flow is Q equals to dV by dt, that is del P K permeability proportionality constant. A is the area, L is the length of the filtered bed, and mu is the viscosity of the filtrate. So these two equations are very important for filtration. So next we are going to discuss about the filtration classification. So we can classify the filtration process based upon the mode of filtration and also the process of filtration. Mode of filtration, that means it can be operated at batch mode or continuous mode. For batch mode, a fixed volume of the suspension or slurry is placed in the filter. Those are separated and then filter is cleaned for the next batch. So this is kind of batch setup, and simple design, low capital cost, and it is very flexible for different slurry concentrations and small scale operations. So, but the main problem associated with batch filtration is lower throughput compared to continuous filtration system. So, kind of batch filtration we can see plate and frame type filtration process, that is batch mode, and uh, shell and leaf filtration, that is also of batch mode. So these are some examples for batch filtration. The next one is continuous filtration, which is by the name you can see that it occurs without interruption. So slurry is fed continuously, filtrate is being removed or separated continuously, and solids are also discharged simultaneously. It has comparatively high throughput, suitable for large scale industries, reduced the downtime, and better suited for the process which requires steady state operation. So example are rotary drum filter. The next one on which basis that we are going to classify filtration process, that is based on the process that we are having. First one is the deep bed filtration. It requires less concentration of the particle. So we can use very dilute slurry samples or slurry source for deep bed filtration. This deep bed filtration is also known as clarification. Now what happens that particles trap inside the media, it just when these are some media, some channels are there, the whole media is this, some channels are there, so particles trap inside the media. So no cake formation onto the surface of the there is no cake formation, and constant resistance and pressure drop is maintained into the filter medium. So the cake filtration that the cake filtration is the next filtration process, which is very similar, which is nothing but the surface filtration. So cake forms on the surface. With increase in the cake width, the pressure drop also increases over the process. And the next one is the cross flow filtration. What happens here, it is quite different from these two because here the feed flows tangentially. So this is the filter medium, feed flows tangentially, and rather than into the filter, it is not flowing in this direction, it is flowing in this direction tangentially. The filter cake, which may cause the blinding for the filter, is substantially washed away during the filtration process, increasing the length of the time for a filter unit can be operational. So it is effective because um, substantially it is washed away, and the feeds containing high proportion of the smaller particle size, they because the solid materials can quickly block the filter surface with dead end filtration. So this difficulty we can overcome using the cost flow pattern for filtration. So in this class we will not discuss the cross flow filtration process. The focusing in this class because we this is one a separate topic we will discuss in the next session. So I hope this difference in the filtration classification is common to you. We will discuss more about this one by one in the upcoming slide. So you can see this is the picture for clarifying or deep bed filtration, where it just passed through the filter medium and it is stuck onto the channels inside the filter medium, the particles. It is nowhere. It is on the surface. It is nowhere on the surface. So this is the basic difference from deep bed filtration and surface filtration, where you can see on the surface all the solid particles are stacked on the surface and only the filtrate are passed through. Where in case of the cross flow filtration, the feed is tangentially flowing. It is not flowing vertically. It is flowing tangentially or parallel to the bed, and only the retentant is out and only the permeate or the filtrate are passed through uh, at the bottom of the filter media. So we will now discuss one by one the filtration process. First one is surface filtration. So what is happening that it is more likely conventional filtration that we discussed. Here the filter media provides the necessary resistance to the slurry and the solid particles adhere onto the surface of the filter medium, and the solid particle present in the slurry starts to accumulate on the surface, forms a bed of the particle which is known as cake, and this cake then provides additional stress, additional resistance to the flow of filtrate, and later on a, a stage arrives when the resistance of the filter media become negligible compared to the resistance which is being offering by the cake layer itself. Now, surface filters are usually used for suspensions with having very higher concentrations of solid, that is above 1% solid concentration by volume, because of the blinding of the medium. So we want to prevent the blinding of the medium, filter medium. So we are maintaining a solid concentration which is very higher, so that everything forms a layer, the solid particles forms a layer onto the surface of the filter medium. So otherwise, for very dilute suspension, the blinding of the filter medium can be a serious issue, but this can be sometimes recovered by introducing some filler aids into the system. That's we discussed that the filler aids are very porous in nature, and they make the cakes more permeable in nature, and um, it often makes cake filtration of dilute and generally difficult slurry is also possible to pass through when we use the filter aids for in the case of surface filtration. So here the surface or the cake filtration, generally two type. One is constant pressure filtration and another one is constant rate filtration. So these two topics are very important. We will discuss detailed way for this constant pressure and constant flow rate surface filtration process. And the filtration, this surface filtration is most widely used filtration in both batch process or continuous process. So in conventional surface filtration process, which is batch cake filtration process, where both the particles and the liquid approach the medium exactly vertically or 90-degree angle, and no attempt is made to disturb the cake or prevent its formation. So there is an alternative way which is known as delayed cake formation uh, or delayed cake filtration process, but the cake is prevented from forming or kept very thin layer by hydraulic or mechanical means. So whatever we are using some scraper so that it always form a very thin layer, not not a pile of or a big um, thick layer. So that is what it is known as delayed cake filtration. The solids are thus continuously stirred back into the suspension, which gradually thickens over the period. The effective particle motion is then parallel to the medium, while the liquid approaches the medium always at 90 degree. The continuous filter thickeners they work on based upon this principle of delayed cake filtration that I have showed in that um, filtration process, that thickening process. Tiller and Cheng have demonstrated that appreciably higher filtration rate and lower cake porosities can be obtained by using mechanical agitator for delayed cake filtration process. A similar mechanism is also used in the so-called bypass centrifugal filtration, where the particles are removed from the medium by using the centrifugal force while the liquid flows through it. So this centrifugal filtration process we will also discuss in the upcoming slide. So now we are going to discuss about the deep bed filtration process. So in deep bed filtration process, what happens that the particles which are very smaller than the medium opening, hence they process through relatively long and tortuous pores where they are collected by a number of mechanisms, maybe gravity, diffusion or inertia, and attached to the medium by the molecular and electrostatic forces. So there is no extra resistance that appears in the deep bed filtration due to the bed of particles on the filtered media surface. The initial pressure drop across the depth filter is generally very higher than the across a surface filter of comparable efficiency. For same efficiency, the pressure drop is higher for deep bed filtration because the particles they just pass through the channels of the filter medium, and from there it pressure drop is very high. The buildup of pressure drop as particles are collected is more gradual for a depth filter. So depth filter are commonly used for clarification, that is for separation of the fine particles from very dilute suspension. Say this dilute is 0.1% by the volume. You can remember that for surface filtration, the volume percent was 1 volume percent, so that was that much concentrated slurry we used for surface filtration. But for deep bed filtration, we generally go for very less diluted slurry, which is 0.1 volume percent solid. In this case, the liquid of the filtrate uh, that we obtained at the end is clear liquid, which is also termed as a sparkling clear liquid. That means it has 0% solid. So now the process, the driving forces for filtration, we have shortly discussed that driving forces are pressure driven or vacuum driven or maybe centrifugal force, and most commonly is the gravity driven. So for the gravity driven we already have discussed, that is the most common one. Now we will discuss the pressure driven process. So here in the pressure driven filtration process, The driving force is obviously pressure difference, which is termed as del P. The inlet feed pressure is introduced at a greater pressure than the atmospheric pressure, and the filtrate or the clear liquid that is obtained, that is collected at a atmospheric condition. So this pressure difference causes the slurry to move across the porous media or the filtrate medium and countering its resistance. So we are now focusing on the constant pressure filtration. So it is when the pressure is applied for filtration, it takes some time to build up to the required level. During the period when it is rising, some filtration takes place. On once the required pressure is attained and it is kept constant over the process is termed as constant pressure filtration. So as the process goes on, the cake it forms over the time and the total resistance offered by the layer of cake against the flow of the filtrate increases over the period, which also cause a decrease in the filtrate flow rate as the inlet pressure is kept constant. So as the pressure is constant, so over the time the flow rate decreases. With the time the cake resistance increases more and more because the cake layer is increasing and more will be the filtrate flow rate decreasing scenario, and eventually the filtrate becomes zero. So then we have to replace that filter medium. So now we are going to derive what will be the equation that is dealing the pressure drop across the cake bed when we are operating the constant pressure filtration. So, so here this is the your filter medium and the cake layer forms here. The cake. So this is the layer for cake. The feed slurry is entering in this way at a pressure P1 and the filtrate is passing through this way at a pressure P2 and the in between pressure that is P dash. So we can just write down that at a constant pressure filtration this pressure drop can be P1 minus P2, which is also can be written as P1 minus P dash plus P2 minus P dash. This del P is the total pressure drop caused by the cake as well as the medium. Suppose the height of the cake its height is L. So the solid starts to deposit over the filtrate medium. Therefore, the cross-section area of the filtered medium is same as the area of cross-section of the bed of solids or the cake. Now, as the feed flows, it flows through the bed of the solid, particles through the voids. So the feed slurry flows through the cake. It it assumed to be laminar fashion. So following the laminar zone, we can follow the Kozeny-Kármán equation, and it tells that for pressure drop in the cake layer is 150 mu Vm 1 minus porosity So this Kozeny-Kármán equation, when Reynolds number of the particle is very lesser than 1. So here what we can say, that in this equation we will use this equation to derive the pressure drop through the cake. So here we can see this is the 1 minus of porosity, this is the volume fraction of solid particles in the cake layer, where A into L is nothing but the volume of the bed, or volume of the cake, where A into L into 1 minus of porosity will be nothing but volume of solid particles in cake. And if you want to get the mass, you just uh, multiply with this. It will be the mass of solid particles in cake. So we will now use this one. This one is the pressure drop in cake layer. So when you um, substitute that value, you can get, suppose let V is the volume of filtrate which has been collected. So C into V will be mass of solid particles present in cake. C is the concentration. C is defined as mass of solid present in cake by volume of filtrate collected. So we can write alternately that the derivation we have did, these two are equal. From there you can easily find out the L equals to Cv by rho P A 1 minus of porosity. So you put this value into the Kozeny-Kármán equation. You will get 150 mu Vm So from there you can get 150 mu Vm by dp square, and you are getting Cv, rho P and A. So from there if you just rearrange this equation, you will get a correlation between the pressure drop across the cake bed. Let me just add one more few slide. So the ultimate equation that we have derived here, that is 150 1 minus of this square rho P into mu V by A. So this term is known as alpha. Alpha is known as specific cake resistance. And this specific cake resistance, so the ultimate equation can be written as del P equals to alpha mu V CV by A, where if you want to calculate alpha, then you can just follow this equation. So we have derived for expression specific cake resistance. The unit for specific cake resistance, that is meter per kg. Similarly, we are going to derive for the pressure drop across the filter medium. So for calculating the pressure drop across the filter medium, there is no theoretical or empirical equations. Everything has been calculated using the experimental value. So pressure drop across the filter medium is resistance is resistance across the filter medium, mu and V. This resistance across the filter medium, the unit is meter inverse. So the total pressure for the filtration process is Pc plus Pm, which is also termed as alpha mu V Cv by A Rm mu V. So this is the whole equation which refers to pressure drop due to the cake and pressure drop due to the filter medium. Where V equals to dV by dt by A, which is meter per second. So if you just rearrange this equation, you will get V by A and Rm into mu. And from that, you will get V equals to del P by this. Now we are going to calculate del V by del V by del T or it is easier to calculate del T by del V. This is one very important equation where Kp is you can see easily. You just have to do the integration from 0 to t. So this one is very important equation for constant filtration process, where Kp has the unit of second per meter cube and B has the unit of second per meter cube. So this one, it represents the cake resistance and this one is represent to medium resistance. So here we can plot the curve between T by V and between the uh, filtered volume. So we can have this kind of graph with a intercept with a intercept that is B equals to Rm mu del Pa, and the slope of this graph represented by Kp by 2, which is alpha mu C by 2 del Pa square. So if the filter medium resistance is very negligible, then B will be 0. At very initial, when T equals to 0, V equals to 0, then we will get the initial volumetric flow rate B equals to 1 by Q naught. And this alpha that we have discussed, this alpha that is the cake resistance, alpha is related to some pressure drop and some compressibility coefficient. S is the compressibility coefficient of the cake layer. So when this S equals to 0, then alpha is not equals to del P, which represents that it is incompressible cake layer. When S not equals to 0, so alpha become equals to del P, maybe S not equals to 0, that means its value may be 0.2 to 0.8. So it falls in the category of compressible cake. When S equals to 1, then alpha will be a function of del P, which represents the cake is completely compressible. So this is how we define the compressibility factor uh, for the cake layer. Now we are going to define the filtration equipment for constant filtration process. So you can see this is the picture for plate and frame pressure filter. So these frames are there interconnected, and the plates, the slurry inlet and filtrate outlet goes here. So in a better view you can see this these are some channels connected through the plates. So the filter plates are there. So the feed is introduced here, and it will go up, it will go in this direction, and the clear filtered would be out. So it follows in such way. So this is the simplest batch kind of pressure filter, that is plate filter, where the slurry is placed between the two vertical plates clamped together by an externally operated screw, which is hydraulic ram. So a series of hollow frames separate the plates, which are placed side by side and hung from two parallel rails on each side of the plates. The filtering medium is placed against the sides of the plate and the slurry is pumped between them. So the slurry pressure presses the pulp against the medium, forcing the liquid through the cloth and leaving the solids as a cake on both surfaces of the frame. So the plates are usually square shaped. Circular plates are also available, but most commonly used are square shaped, which is having some certain diameter you can check. Now in operation, the feed in the form of slurry is pumped in through a common channel, entering the filter through the individual ports. This ensures a uniform distribution of the feed in each chamber. So the feed can be charged either through the top or the bottom of the ports in the frame. The filtrate leaves the individual filter beds through the port that I have shown in the figure through the common discharge channel. For washing the cake, the same hookup for feed and discharge pipes are connected to supply the wash water and to discharge effluent. The cake is recovered by dismantling the whole setup for plates and frames. Steams are also used sometimes to assist the drying of the cake, filter cake. So the next thing we are going to discuss about one numerical. So we will come back to the numerical at the end maybe. I will just go through some different concept, that is constant rate filtration. So in industrial situations where the constant volume rate of the flow of the filtrate is often required to meet the demands of the downstream operations like flotation circuits. To maintain the productivity of the plant, the filtering pressure has to be increased. Therefore, we are maintaining at a constant rate flow rate. It is therefore necessary to have a relation between the volumetric flow rate and the pressure. In this process, as the cake resistance comes into picture, we increase the feed slurry pressure and such that the pressure drop remains constant with respect to time. Hence, the flow rate also become constant. With the time, as the cake resistance increases, input pressure also increases, which exactly counterbalance each other, and we obtain constant rate filtration. So here we can see that for the constant rate filtration, the filtration this one dV by dt A. So here we can also write that cake resistance is, we have derived, so for incompressible cake we can write del Pc, which is related as this equation where Kr equals to, so this one is related to constant rate filtration and S is the compressibility factor. So now we are going to the next part, that is the vacuum filtration, where the driving force is vacuum. In this case, pressure difference also plays major role, but the inlet feed pressure maintained at one, while the vacuum is maintained at the other end. So, due to the vacuum, the slurry from the filter media is being pulled or sucked into the system at the outlet, and this is how the filtration proceeds. This type of filtration is carried out by continuous filtration system such as rotary drum filtration, where the 15 to 25% slurry is the drums are slurry submerged. There the vacuum filtration is generally used for those liquid having very high boiling point or very high very high volatility. So here you can see two figures denoting rotating drum filter and rotating disc filter. Those are operational principles are same. Instead of drums, and there are some disc plates are placed. So here you can see that rotating drum contains filters consist of horizontal drum with its bottom one third is immersed into the tank. Slurry has been filtered. The drum shell is perforated and covered with shallow compartment which serves as a draining grid. This grid is often covered with metal gauge which in turn covered with filtering cloth. The end of the drums are either open or closed depending on the spider through which the trunnion passes. Each sector of the drum is connected from inside to the centrally located complex valve system. The valves has ports connected to three systems, that is vacuum, compressed air, and water line. Two of these rotate with drum, while the others are stationary. The valves acts in a manner such that one third of the portion of the drum is immersed into the slurry under the vacuum condition. The adjacent half of the drum is under vacuum but could also be switched to dry air pressure. The remaining portion of the drum is under positive pressure, which helps to dislodge the crack from the drum surface. So, in the first stage of the filtering cycle, the filtrate is drawn into the drum, leaving a cake of solids adhering onto the medium surface. The drum continues to rotate, and the cake is first segments emerged from the slurry and is exposed to the atmosphere, where these are washed under vacuum conditions and range the adhering impurities or solid. The drums then enter the drying section, where the cakes are dried by drying air. On further rotation, the drum enters the final zone where the cake is blown out using some reversed air pressure and discharged. So there are several methods that are followed for discharging the cake. The most common is using a knife or scraper against the cake along the entire width of the drum. You can see there is one scraper. In the roller type, discharge type, um, rotating drum filter, scraper rolls rotate also in the opposite direction, so it helps to scrap the cake layer onto the surface of the medium. The scraper roll, which is placed against the cake at a suitable distance to slightly compact and peel off the cake. The surface of the scraper roll is capped with a rubber material, so scraper knife keeps the scraper roll surface clean always. This technique of cleaning the drum is particularly suited for very sticky and clay cakes like that of bentonite or this kind of clay material. This is also suitable for alkaline red mud slurry produced in the alumina industry bare process. Now we are going to discuss about the next part, that is rotating disc filter. So basic design is always similar to the vacuum filter, like the rotating filter, drum filter, but the only difference is number of discs are placed in parallel. The lower end of the disc is attached to common horizontal pipe which passes through the center of all the discs in the unit. The central pipe is designed to form trunnion of the unit and serves as a conduit of vacuum and pressure lines. The distance between the filters is fixed and then passed to collect cake off the filter surface. Each disc um, is designed to operate separately with its own slurry tank, and more than one type of pulp can be filtered simultaneously. So in this picture you can see there is scrapping of the cake is happening, and you can have a good visualization in the video. Next one is we are talking about centrifugal filtration, where we are using centrifugal force. So by using the centrifuge, solids are separated from solids that form a porous cake can be separated from liquid. The process of centrifugation takes the advantage of difference in the specific gravity of a fluid and particulates within it. It rapidly accelerates its separation process using the centrifugal force rather than gravitational force. So the slurry is fed to the rotating basket. Here is the picture, which has the perforated wall. So, or the metal cloth is there. Pressure resulting from centrifugal action force is much stronger than the gravitational force. So, within very short time, the solids are separated and is collected inside the basket. If the feed to the basket is then shut off and cake of the solids spun for short time, much of the residual liquid of the cake drains off the particle. Such way it has been dried also. So when the filtered material must be subsequently dried by thermal means, and this will considerably savings may result from the use of centrifuge. Now the whole of the thing we have discussed. Now we are going to give a glance that what are the filtering medium we are using for filtration process. The filtering medium commercially available with various pore size and pore size distribution. Thus, the separation of the particular particles in the slurry, appropriate medium can be chosen suited to the size distribution of the solids in that slurry. The medium you should choose should be non-reactive and preferably non-weighting to the slurry, and media generally used in industry. Those are woven fabric or woven synthetic material or non-woven synthetic material. So the woven fabrics are made of plain clothes. Uh, Both twill or satin clothes are much stronger than the plain clothes because it will be much easier to scrap off the cake from there. So the surfaces are sometimes flattened to reduce the pore size. Satin finished clothes have very polished surface, so it is much easier to collect cake from the plain surface. All the cotton materials are attacked by alkaline or acidic slurries, hence they are best used under neutral conditions. Cotton and cellulose-based webs shrink or stress under load and sometimes swell also. As a result, the structure or pore size or pores are getting affected over the period, and also it affects the size distribution of the particles in the filter. So the woven synthetic material usually they are using polypropylene or polyesters or various polyamides. This strength of the synthetic fibers are way far greater than the cotton fibers. Synthetic media of wide range permeabilities are available. Now the manufacturer usually indicate air permeability. So air permeability for nylon cloths, if you are considering, that will be very lesser than the polypropylene. The non-woven synthetic fiber cloths are made from randomly assembled synthetic fibers and pressed together. The fibers are interlocked, producing cloths of high permeability and adequate the strength for use in the batch filter process. Now the very important part, that is the use of the filter aids. So when the slurry are very dense and impermeable in nature, so it plugs the filter medium. So these slurries are therefore spiked with some material that will keep open the porosity and the permeability of the cake. So it should be also non-reactive. So these filter aids are used in the form of powder with known size distribution. The normal filtering aids are used diatomaceous earth, just like fuller earth or kieselguhr. These are used for Filter rate, cellulose material, asbestos fiber, sawdust, or carbonaceous particles like activated carbon. So, in addition to hard aluminosilicate materials, these are very commonly used aluminosilicate materials or minerals. The filtering aids are obtained in the form of crushed and screened powder from minerals with several grades of pore size and pore size distribution, specific resistance as well. In continuous filtration process, the filtering surface is first coated with filtering aid material, usually achieved by suspending the filtering aid in the form of slurry and then pumping to the trough between the five filters. The filtering surface is then immersed into um, the trough. So this way these are being coated, or it can be mixed with the cake, usually discarded after filtration. If the cake is important for your interest, then the filter aids can be chemically treated or physically removed. The filter aid is added. The initial rate of filtration first increases when it is being added. After optimum content concentration of the filter rate, the rate of filtration is highest, but after adding more and more filter rate, the flow rate will decrease. So it will follow an optimum rate like this. With increase in flow rate, the optimum concentration of filter rate. So when we are focusing on the last part, that is the cake washing. So after filtration, the filter cake must be washed in a packed bed condition with void space, that is usually being um, filled with some solution. So if the cakes are not washed after filtration, solute may retain as an impurity, and sometimes washing is also required to recover the valuable solute for reuse. Often cakes are washed with water. Other than it can be also washed with solvent depending on the remove some solutes specific. If the solids are waste product, then it is not washed even. Also, it can be washed to um, regulate the pollution control regulations. Rate of flow of wash liquid or volume of the liquid needed to reduce the solid content of the cake to the desired degree are important quantities for designing and operation of a filter process. Volume of the wash liquid required for near completely removal of the solute is very greater than volume of the solution retained on the cake after filtration. So volume of the solution left in the cake can be calculated by this equation. During the first part of the washing, the displacement of the wash liquid passed through the bed, pushing solution ahead of it, and the solute concentration in the exit streams become equal to the initial concentration of the solute in the filter. So the displacement wash can remove most of the solute with minimum volume of wash liquid if the bed has uniform pore size and ideal plug flow condition. Effluent concentration remains constant until all the solutions was displaced and then drop abruptly almost to zero. Some of the void space in the cake are in pockets, and so there are still retained solute when solution has been displaced from the main channel. So from the pocket solute diffuses out into the main channel, there is rapid drop in the effluent concentration. The diffusion stage starts when the 70 to 75% solution in the cake has been displaced. Additional holdup in the pore or lower effective diffusivity prolong the diffusion stage for a bed of particles and require more wash volume for given better percentage of solid removal. Finally, the washing of the cake should be stopped when the value of the unrecovered solid is less than the cost of the recovering solid. So we have also um, completed most of the most of the part for today's session. Now we will solve one numerical. So this numerical tells that in a constant filtration process, slurry of 20 kg of calcium carbonate per meter cube is added with water. Following the data that has been plotted, some values are given. You have to calculate the specific cake resistance and filter resistance. So for constant filtration process you have to follow this equation, right? So while you can, when you plot this equation for this you will get this slope as kp by 2 and intercept is b. So the slope value kp by 2 equals to, for first case it is 12.5. So the kp equals to 25 into 10 to the power 6 second per meter to the power 6. You have to follow the unit as well. And for first case the b equals to, and what is the value of, and after solving this equation you will also get the value of alpha. Alpha equals to kp del p a squared by mu into c. So from there you will get alpha 1 for first data point. Del p 5 into 10 to the power 4, and you will put all the values that is noted here. You will get value 5.06 to 10 to the power 11 meter per kg. And following the equation you will get the a by mu, it will be 1.1925 10 to the power 11 meter inverse. So the same process you have to follow, repeat for the second data set, and from there you will get alpha 1, alpha 2, and you will get rm1 and rm2. So when you know that, your equation for compressibility, it is alpha equals to k into del p to the power s. So you can have alpha 2 alpha 1 by alpha 2 is del p1 del p2 to the power s. So here alpha 1 you have already calculated 0.62 10 to the power 11. Alpha 2 you can calculate and you can have this value. Del P1 5 into 10 to the power 4 35 into 10 to the power 4 S, and when you solve you will get S equals to 0.348, which represents this is incompressible. Sorry, this one will be compressible. Okay. So we have discussed lot of things regarding filtration process. So mostly we have discussed two types of filtration process, which is deep bed flow and surface flow. But for the cross flow, we will have separate class for that, and we will discuss in the next class. So this is what for today's session. If you have any queries, you can let me know. If anything required clarification from today's class, you can join in the next session and you can ask your doubt anything. So thank you. We will meet in the next session.